Today we will be solving this truss. The first step in solving this truss is determining if the truss is statically determinate or not. That means the truss is just not moving. So the formula to solve this is 2j equals m plus r. That means twice the number of joints equals the members plus resistance forces. Because we have 6 joints, 9 members, and 3 resistance, that both sides equal 12, so that means this truss is statically determinate.
The second step in solving a truss is calculating the moment of inertia around any point, really. So we're going to choose the moment of inertia around the A point over here. So the formula for moment of inertia is the distance to the first force. So in our case, that's 9 times the force itself. So 9 times 500, and then 25 times 500, and so on. There it is modeled in the equation. And in regards to forces being negative or positive, if the force would cause the apparatus to move in a clockwise direction, that force would be negative. If it caused the apparatus to move in a counterclockwise direction, the force would be positive. So there it is simplified, and then simplified some more, and then there's the answer. Now we calculate the moment of inertia around D, because the reaction force at A in the x direction is perpendicular to D, it does not affect its rotational movement. So, using the formula from the last one, we're going to plug in our values, simplify, and then we get that the reaction force at the A point in the y direction is 411.76 pounds. The fourth step in calculating the forces acting upon a truss is in our case to sum the forces in the x direction. We're going to do this because we only have one unknown left. We know the reaction force at D in the y direction, reaction force at A in the y direction, and because of this, we only have the reaction force at A in the x direction left to calculate. And D does not have a force in the x because it is a roller support, while the pin support at A does indeed have a reaction in the x. So, the formula for this is modeled as the summation of forces in the x direction equals 0 because the truss isn't moving, equals all the forces acting in it summed together. So we only have the 250 pounds up here and the reaction force at A in the x direction, so we can calculate the reaction of A in the x direction is negative 250.
Now that you've found the reactionary forces around A and D, draw out each joint with its members and forces in the same orientation as they are in the real truss. Also make a list of each member force that you need to find by the end of this truss calculation. Next, you'll want to draw a larger diagram of one of the joints with the fewest unknowns, which in this case would be A or D. We'll need to find the angle at joint A so we can determine the force supplied along member AE. To do this, we'll need to look back at the truss side lengths and draw a triangle containing joint A and its two members. Using trigonometry, we can do reverse tangent to find the measure of the angle. We will take the opposite side divided by the adjacent side in relation to the angle and put that in our calculator. When we put this in our calculator using reverse tangent, we find that the angle equals 53.13 degrees. Don't forget to make sure your calculator is in degree mode and not radian mode. For the forces around A, we need to make sure that the sum of all x forces equals 0 and that the sum of all y forces equals 0. Write down the summation equations using force variables and known values. Because our summation of y forces only had one unknown, we can quickly solve for the force on member AE in the y direction. As we solve for force on A to E in the y direction, using this diagram we can see what it really represents. By using trigonometry, we find that the force on member AE is negative 514.7. It's negative because it shows that that member is under compression. If the number is positive, that means the member is under tension. After solving for the force on members next to A, we can now either solve E or D because they both have two unknowns and a load to help us find the other values. You always want to try to solve the joint with the least amount of unknown forces acting upon it. We chose to do E next, but you can do either E or D because they both have the least amount of unknown forces left.